Yo, 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 yo! Welcome back. We're doing Maths Quest 2012 Maths Speed Chapter 8 review. Question 18, the last question in the chapter reviewed. Alright, this better be good. Alright, question 18. Alright, we're going to diagram on the right. Okay. Okay, say question A. Find the derivative of x, ln x. Okay. So, y is equal to x multiplied by ln x. Right? So this is like a product. This is a product of two. So we have to, when you derive it, we have to use the product rule. All right, the product rule is y dash equal to uv dash plus vu dash. Right? All right, so let's decide what the u dash and v dash is. So u is equal to x, u dash is equal to 1. V is equal to ln x, v dash is equal to 1 over x. That's the derivative of ln x. So I dash is equal to x multiplied by 1 over x plus ln x multiplied by 1. Y dash is equal, now this cancels out, becomes 1. So this is ln x plus 1. Yeah, ln x plus 1. So that's it. That's question A. That's the derivative. All right. Question B. Hence, find an antiderivative of log e, ln x. Right. Now, we're trying to integrate ln x. Right. Because if we follow the procedure we did in question A, we know that deriving x multiplied by ln x give you ln x plus a constant, right? Plus a constant. So right now, in here, we also got a constant too. If you didn't realize, it's a 0. We just don't write it. It's also a constant. So ln x plus a constant here, same as here. So you can literally say when you integrate this with respect to x, you will get x ln x plus a constant. Right? You always got the c there. You always have the c there, and plus, well, this is 1, right? This one becomes an x. This one becomes I think the idea is just it's equal to ln x. So the integrate of ln x is equal to x ln x plus a constant. Okay, so I think that's what they're trying to get, like the idea. So they showed us when you differentiate x ln x, you get ln x plus a constant. So when you integrate ln x, yeah, you should get back x ln x. All right, but you know, we can do it in a much better way. We don't have to guess. We don't have to see the pattern. All we can do is what we called substitute by integrating by this is integrating by parts. Integrating by parts. So this is right out of that, right? Because we are integrating ln x. All right. Now, the integrating by parts, I will especially make another video just to teach you guys how to do that. I think all year 12 student, Maths B student, or even Maths C student should understand this, should know how to do this. You should need to follow pattern. You should actually know the method. All right. So I'm just gonna go, straightforward into the substitute by parts here, integrate by parts here. So, and like I said, I will make another video to explain it in the detail. So I know u dash integrating u dash dv. So this is the rule for the integrating by parts. Right? Now this bit is supposed to be this bit here. So integrating, integral, we got good. So now we're gonna see which one is the u and which one is the dv. But we only got one here. We only got ln x here. Now ln x here, don't forget there's always a 1 in front of it. All right, so in this case we let u equal to something that we can differentiate, right? We can differentiate ln x, right? You can't integrate ln x, you can differentiate ln x. Differentiating ln x give you du over dx, give you what? It gives you blah, 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 1 over x, right? Just when you differentiate ln x, you get 1 over x. So when you move the dx to the other side as well, so du's give you 1 over x dx. Yeah. All right. So since we let u equal to ln x, we must let this whatever left. So we're already done with the u. So whatever left is this one and this one. So we let, then don't forget there's also a 1 in front of it here. All right. So let 1 dv is equal to whatever we got left in here, which is the 1. And what is that differentiating with regards again? Should be dx. Yeah. And so that means v is equal to x. Okay. All right. So then we can write the function. So integrating ln x now is equal to, with respect to x, is equal to u times v, u times v. So x times ln x minus, right, look at our equation on top, minus integrating phi du. Now phi is just x. Du, we got this expression here. Right? Now this one just cancels. So that just means equal to x ln x integrating 1 with respect to x. Alright, that's a minus sign between. And that's for, therefore, at the end is equal to minus x. Yeah? Plus c. Okay, so that's what you get for integrating ln x with the method of by parts. This is fascinating. This is so good. Once you understand this, I don't know if it's going to help you in the test or not, but once you understand this, you can integrate anything. Well, there's other methods as well, but look, it just open more path for you. You don't have to follow stupid rules that stupid pattern that you don't see, that you couldn't comprehend. I'm not saying the pattern doesn't work. I'm just saying some people just can't comprehend the pattern. And if there's a better way, why not learn the better way? All right. So anyway, integrating ln x gives you x multiplied by ln x minus x plus c. Great. So that's question B. The cross-section area of a platform is shown on the right. Okay. So now they talk about the pictures. All measurements are in meters. Good. Our units is in meters. Find the height of the platform. So we're looking for this from here to here. Now we know from here to here is 1. All we have to find out is from here to here. What is it? All right. So we got the function f of x is equal to log ln x here. And we know this particular point is e to the negative 2. Right? So we can sub in e to the negative 2 into the x to find this particular y value. Right. All right. So y is equal to ln x. Sub x equal to e to the negative 2. So y is equal to ln e to the negative 2. Now with your log law, index law, you should know you can draw the power to the front. Now ln e, when the base of the log and whatever inside the bracket is the same, that's equal to 1. So y is equal to negative 2. So this is negative 2. All right, I should also put negative 2 meters because all the units are in meter. So therefore, the height of the platform is so it's 1 minus negative 2 equal to 3 meters height. Oops, battery is going low. Okay, 3 meter height, 3 meters. All right, just put it like that. Okay, So that's 3 meters. All right, that's C done. Okay, quickly. Question D. The cross-sectional area of the platform. Oh, Lord. Okay, so the cross-sectional area. So the first, all right, we're going to break this in 2 parts, all right? We're going to find this rectangle first, all right? And then from this point to that point. Now, we know this point is e to the negative 2 and negative 2, right? And we know this point is e, because it tells us that. I don't know the y value, but it doesn't really matter in this case. All we need to know is the x value. All right, so let's find a little small rectangle first. So we've got the section 1, and this is section 2. Okay. All right, I have charged up my battery, so the battery crisis is gone. Okay, let's continue. All right, so we've got the section 1 and section 2. All right, let's work out the easy one, which is the section 1 first. All right, so section 1 area. Section 1 area, right, is just equal to, it's a rectangle, it's just length times width, right? Now we know that the length, let's call this the length, yeah? The length of the first rectangle, section 1 is from 0 to e to the power of negative 2, so that is e to the power of negative 2. And the width is, we got it before, I think it's 3. Yep, it was 3 meter high. 3 meters. Yeah, they're both meters. All right. So the area of the first one is just equal to e to the negative 2 multiplied by 3, give you 3 e to the negative 2 meter square. All right, that's easy. That's extremely easy. All right, but let's go to section 2 area now. Now section 2 area is the one that we have to integrate. Integrate from e to the negative 2 to e. If we have a look on the graph, so we are going from this point to all the way to this point, right? And it's always top minus bottom, and then integrate with respect to x. Yeah. All right, so which one is our top function? I believe the top function is a straight line, right? The top function is a straight line of y equal to 1. Yeah, that's a straight line. That would be our top function. Let me just remember, okay, so log ln x, okay. So the top function will be 1 minus the bottom function, which is ln x. All right, expand the bracket. It will be just, what do you call it? 1 minus ln x. Integrating with respect to x. All right, now, remember, you can distribute the integral sign into both of them, making them this way. Yeah, making them look like that. Right? Now, we know that integrating x, well, we're integrating 1 with respect to x just give you x. Right? So, give you x, e to negative 2, e, and then minus, now we did the integration of ln x before, right? So that was this one, ln x, x multiplied by ln x minus x plus c. But in this case, we don't have a c because it's definite integral. So it will be just be x ln x minus x from negative 2 e to the power of negative 2 to e. Yeah, just these two. Okay, I'm gonna write it here. All right, so we can put the number in now. Yeah. So x, sorry, not x anymore. So this would be e minus e to the negative 2. Right? So that's the first bracket. So this is what this bit becomes. Yeah. The next bit is still a negative here. Next bit becomes e times ln e minus e minus, now this is a big bracket here, e to the negative 2 times ln e to the negative 2 minus e to the negative 2. Right? Okay. Now we can expand the first couple brackets. So this is e minus e to the negative 2. Good. Minus, alright, put a big bracket around here. Now, e times ln e. Ln e is 1. Okay, so log e is 1. So that is just e minus e in there, right? Which is gone. Alright. The next one is e to the negative 2 multiplied by ln e to the negative 2. Now we know ln e to the negative 2 is just negative 2. So this is just e to the negative 2 multiplied by negative 2 minus e to the power of negative 2. Yeah? Oh, a lot of e's. Alright, be careful with your algebra, you know, just work it out one by one, step by step. Don't miss out the negative sign, the positive sign. Do not miss them out. Alright. Okay, so this is e to the negative 2 times negative 2 becomes negative 2e to the negative 2 minus e to the negative 2. So we're just minusing one more. So that gives us negative 3e to the negative 2. Right? Now, when you expand the most inner bracket right now, negative becomes positive. Right? But don't forget, there's another negative bracket, negative sign expanding into the brackets. Minus 3. Yeah? And now that is the same as e minus 4e to the negative 2 unit square. Because that's the area, yeah, of section 2. Okay, got section 1, got section 2. So therefore, total area is equal to what we got before. 3e to the negative 2. 3e to the negative 2 plus e minus 4e to the negative 2. So, you know, that plus is just a bracket there. And the plus doesn't really change anything inside the bracket. So we can still write it as this. Yeah? So we've got positive 3 lots of this minus 4 lots of this. We're getting 1 lot left. So this is e minus e to the negative 2. Unit square. Whew, finally. That's the area. Final answer. Total area of question D. Yeah? And then question E. Find the volume of concrete required to build this platform if it is 20 meters long. Alright. So to find the volume is equal to area multiplied by another dimension. Alright, so in this case would be the length. So it would be e minus e to the negative 2 or multiplied by 20. So they give you 20e minus 20e to the negative 2. Unit. Oh, so it's not unit square. We only call it unit, right? It's in meters. This is meter cube. Silly me. It's not unit square. It's no, not unit square. we've got a unit. It's meter. So it is meter square. Alright, change it. I don't know how much mark they will give it to you if you put unit square here instead of meter square. They would get full marks, I suppose. Yep. Good. Good. So that's it. That's the end of question 18. Finally. Whew, chapter 8 review all done. Alright. A pat on the shoulder. Okay, so let's go into the commercial break, and I believe when we come back it will be chapter 9.